Okay, we're live. Section 10.7 is complex numbers. First, we define an imaginary number as a square root of a negative. So you can plug in any negative number you want in there. For instance, -4, and that means it's an imaginary number. So this came about from trying to solve certain quadratic equations. For instance, x squared plus 1 equals 0. If we subtract 1 from both sides, we get x squared equals -1. Okay, and then the way we get rid of that square is we take the square root of both sides. And we get x equals the square root of -1. Actually, plus or minus square root of -1. But it's a new type of number that didn't exist anymore. So we define the square root of -1 as I. Can you all remember that? Okay. And I squared, if you square both sides, is -1. So these are the two things we have to memorize for today. Okay. Well, if we have something else inside there other than -1, we can break it up. So square root of -4, like we dealt with before, we can take out the square root of -1 as I, and we're really left with square root of 4 times I, which is 2I. Are there any questions about this so far? Okay, why don't you guys tell me then, what is the square root of -16? Good. 4i. All right, a complex number is always written in the form of a plus bi. Okay, so for instance, a and b are real numbers. A is called the real part, b is called the imaginary part. Okay, so for instance, 5 minus 3i. What is the real part? 5. What is the imaginary part? Not quite. -3. It doesn't include the I. The imaginary part is just the number, the coefficient of the I. -3. Okay, well, no matter what, we can always put it in this form. So 5 minus 10i over 5. This is something that might happen quite often. But this is not an a plus bi form. How would you put it in a plus bi form? Divide it. So you'd say 5 divided by 5 and -10 divided by 5i, 1 minus 2i. So you always need to split it up into the two parts. The real part comes first, imaginary part comes second. Right, so if you ever have an I in there, split it up in a plus bi form. All right, next, adding complex numbers together, you just add like terms together. So a plus bi plus c plus di. We add a plus c, we add bi plus di. All right, how would you imagine you would do the subtraction? Same way, only difference. Just distribute your minus sign, because it's a binomial. A minus c plus bi minus di. And you're adding the like terms together, the real numbers and the imaginary numbers. Okay, so example 1, let's simplify square root of 12 minus the square root of -18. Any ideas? Yeah, simplify the radicals. Okay, so how do we simplify square root of 12? Square root of 4 times 3. You guys agree with that? Yeah, good. All right. Now the new part is the next one, right? How do you simplify negative square root of -18? All right, square root of I'm actually going to put as negative 1 times 9 times 2. Just so we know the square root of negative 1 is I. Alright, so we have a square root of 9 is a 3. Square root of negative 1 is an I. And we have square root of 2. Any questions about that? So you always take out the negative inside the radical to make it I. Alright, now convention is you have to write it as A plus BI, right? So that would mean what? Alright, so technically speaking, we would write it like this. But this, you were right in how you said it. Don't write this. The reason we don't write it like this is because sometimes people are careless with their radical, and it goes over the I. The I can't be inside the radical. You took the negative out, right? This is different. It's not a complex number. It's some other number that we don't even discuss. So the I always goes between or right in front of the radical. That way we don't confuse it as being inside of it. That's just convention. Okay, so what is the real part of this complex number? 2 square root of 3. What is the imaginary part? Negative 3 radical 2. It's the coefficient of I. I is multiplied by negative 3 radical 2. Alright, example 2. Well, let's just start off by taking out the square root of the negative. Good. So I took out the square root of the negative, and I took out an I. Then I split up. I know the square root of 144. I know the square root of a squared and b to the fourth. What I have left over is ab. You guys remember this from the midterm? Yeah, okay. So finally, what do you get? Well, square root of 144 you said was 12. What's the square root of a squared? And b to the fourth? B squared. And then we have our I square root of AB. Alright, any questions? Alright, cube root of negative 8, a to the fourth. What do you get?
You get 2, it's 2. Cube root of 8 is 2.
Yeah, cube root of 8 is definitely 2.
2i, a, 2i, a, yeah.
See, it's funny because you guys got this right on the midterm. I remember you getting it right on the midterm. This one, a similar problem was on the midterm, but there weren't any i's. Why shouldn't there be an I here? Cube root. What's the cube root of a negative? Negative 2. Alright, so remember, it's only square roots of negatives that are i's, right? A cube root is just going to be a negative number. A fourth root, well, you're not going to have those. It's a different thing completely. Fourth root of a negative is not an I either. It's actually a square root of an I, which, let's not even talk about it. Okay, so don't confuse that. Don't just take out an I because it's negative. It has to be a square root of a negative, right? Alright, adding complex numbers together. We have 6 minus 9i minus 4 plus 2i. What do you get? Why don't you guys do this? It's pretty easy. All right, what did you get?
Minus 11.
Yeah. What minus 11i?
2.
Oh, you said 2, sorry. All right, yeah, 6 minus 4 is 2, and negative 9i minus 2i is negative 11i, and that's an a plus bi form. So that's our final answer. All right, this one's a little bit less obvious. What do you do first? Distribute the negative? Sure. Always to the right, so negative 7 plus square root of negative 8. Now what? All right, you always want to take out the i's. Oh, whoops. The i's. Just kidding. All right. So what do you get? Minus I root 50, which is 25 times 2. Minus 7 plus I root 4 times 2. Okay, so 12 minus what? Minus 7 plus... All right, we add like terms together. 12 minus 7, 5. Negative 5i root 2 plus 2i root 2. Can we actually combine those? Yes, and that's because everything is the same except for the coefficient. Good, so those are like terms. What's that? Yeah, you'd have to leave them separate. You could maybe write them together and factor out the I. Yeah. All right, any questions? All right, let's go on to multiplying complex numbers. So we need to be careful about square root of negative 4 times square root of negative 16. In the past, it's something that we haven't worried about multiplying, right? We've said things like square root of 2 times square root of 2, we could say square root of 4, right? Which is just simplifies to make 2. But if they're not real numbers, we can't do that rule. So I just want to point out why that's true. Yeah, you take out the I. All right. If you had multiplied negative 4 times negative 16, what do you get? Positive 64. What's the answer to that? 8. But now we know we always take out the i's first, right? So what do you get? 2i times 4i. So 2 times 4 is 8. I times I is I squared. And we all memorize what I squared is, right? Negative 1. So we actually get negative 8, not positive 8. So take out the i's first, and we work with those. All right, so part A. Why don't you guys try that out, multiplying those. Okay, so you guys failed. 6 times 3, 18. 6 times 2i. 5i times 3. And 5i times 2i. Good. So we have 18 plus 27i. We add the like terms together. And you said I squared is negative 1. So that's a negative 10. 8 plus 27i. All right, part B. I think you guys will enjoy that one. You want to try it out on your own? Okay. No. All right, let's FOIL it. So first we have 6/5 times 2/3. Then we have 6/5 times negative 1/3 I. We have 3/5 I times 2/3. And then 3/5 I times negative 1/3 I. All right, so what is 6/5 times 2/3? All right, let's reduce this to 1 and 2. So actually it's 4/5. All right, the next one, we can reduce the 6 and the 3 again. Negative 2/5 I. All right, the next one is a positive 2/5 I. No, trust me, you'll enjoy it. All right, and then 3/3. We get what? Negative 1/5 I times I. Positive. So we get an I squared. So negative 2/5 I plus 2/5 I cancel. We end up with 4/5 minus 1/5 times negative 1, because I squared is negative 1. So what's our answer? 4/5 plus 1/5, yeah, that's 1.
I didn't make these points, so that's why I keep it 15
Oh, okay. All right, how would you guys go about doing part C? Yeah. All right, try part C by yourself. All right, so what did you do first? Okay, so hopefully you didn't distribute your exponent, but you FOILed. Okay. 2I times positive 16 plus 4I plus 4I. Negative I times negative I is positive I squared. So 2I times 16 plus 8I. I squared is negative 1. So we get 2I times 15 plus 8I. Then we distribute the 2I. 2I times 15. 30I, then 2I times 8I. All right, so that becomes a negative 16. Good, and we have to write that first. Negative 16 plus 30I. Do I need to factor out the negative, or factor out the 2? No, yeah, that's simplified. We perform every operation we can. Good, any questions about any of this? All right, maybe I want to quiz you really fast. What is a conjugate? Opposite sign. So what is the conjugate of 5xy, x squared y, plus 7z? 5x squared y minus 7z? You guys agree with that? Okay, so it's two terms, right? And the sign in the middle switches. Those are conjugates, right? Well, guess what? Complex numbers, a plus bi. What is the conjugate of a complex number? A minus bi. Does that make sense? Well, there's a super powerful result when you multiply conjugates together. And I really need you guys to memorize this. So multiply a plus bi times a minus bi and show me what you get and why it's cool. Yes, why it's cool. Answer, I'm not sure. Okay, so you followed it, right? A times A squared, A times negative BI times A. And so those cancel, right? And then BI times negative BI. I'm just going to write it out because a lot of people are messing up on this. Plus BI times negative BI. Alright, so I end up getting A squared. What is positive B times negative B? Negative B squared. I times I is I squared. So we simplify I squared to make times negative 1. Yeah, so it becomes A squared plus B squared. So, what's so cool about this?
You don't need to worry about that.
Yeah, at the end of the day, there's no i's. It's a real number. No i's, right? The other thing that's cool about it is when you square a number, it's positive, right? So we know that it's always positive. A squared plus B squared, we're adding two positive numbers together. I guess it could be 0. It's always greater than or equal to 0. Okay, so if I want to eliminate an I can multiply by a conjugate. Alright, so dividing complex numbers. A fraction is in simplest form where there is no imaginary number. When there is no imaginary number in the denominator. So basically, imaginary number is square root of negative 1, right? Remember, it's unsimplified if we have square root in the denominator. So for that reasoning, we cannot have I in the denominator. So starting off with part A, any ideas how I could get rid of the I in the bottom? Multiply by what? What's the conjugate of negative 4i? It is 4i. You could put the negative on the top, but I want to get rid of the I. Okay, so that's interesting that you said conjugate, right? Because what is 0 minus 4i as a complex number in A plus BI form? Yeah, 0 minus 4i, right? So what's the conjugate of that? 0 plus 4i. You could multiply by plus 4i, but really all I care about is I times I is I squared. So you don't even have to multiply by the negative 4i. It's kind of excessive. You just need to multiply by I. But if I do that, it changes my fraction, so what do I need to do? Alright. Why is multiplying by the top help me? Yeah, I over I is 1. Okay, so what do I get when I multiply this out? Good. Distribute the I on the top. 2i minus 3i squared over negative 4i squared. So I have 2i plus 3. So negative 3 times negative 1 is positive 3. Good. And on the bottom, a positive 4. Negative 4 times negative 1 is positive 4. But you do. You have to rewrite in A plus BI form, so we need to split the fraction also. It's a complex number because there's an I in it. Three fourths plus 2/4 I, which reduces to 3/4 plus 1/2 I. Are there any questions about any of this? All right, part B. Okay, multiply the bottom by the conjugate. So if there's two terms on the bottom, you want to multiply by the conjugate. You have to memorize that trick. A lot of things that people do by accident is they multiply by I over I. What's the problem with that? If I multiply by I over I, why wouldn't that help me? Yeah. If I distribute it, I would have 3I plus I squared. It only got rid of this I, but created a new one. Right? So the trick here, whenever there's two terms on the bottom, two terms, it means you want to multiply by the conjugate. Okay, so what is the conjugate of 3 plus I? 3 minus I. But you have to do the same thing to the top and bottom. Okay, so this one's going to be a lot more work. On the top, what do we get? Three times 1, 3. 1 times negative I. Negative I. All right, negative 3I times 3. Negative 9I. And negative 3I times negative I. Negative times, yeah, it would be negative 3 if you simplify. That's a lot to do in your head, right? Two negatives canceling, adding another one in there. So I'm going to write negative times negative is positive 3I squared. Yeah, which becomes a minus 3. Okay, on the bottom, when I FOIL, 3 times 3 is 9. Then I get a negative 3I, a positive 3I. And you know what? Multiplying by the conjugates, those middle terms will always cancel. Okay. And then positive I times negative I is negative I squared. Okay, so I end up getting, I'm going to rewrite it, 3 minus 3. Those cancel, minus 10I. So this is negative 3. I wrote it down here. On the bottom, I get 9 plus 1. So my final answer, negative 10I over 10. It's negative I. All right, any questions? All right, part C. How do you go about simplifying square root of negative 300 over square root of negative 100? Yeah. So that what will that make? 10I square root of 3 over 10I. All right, square root of 100 is 10, so you have a square root of 3 left over. Good. 10I over 10I, square root of 3. All right. Last thing for the day, not the day, for the lecture. I to the 9th power. All right. So to do all of these ones where you have I to very high powers or to very low powers, you actually have to notice the pattern. It's not actually 1. It's not negative 1. It's not negative I. It's positive I. Alright, but in order to do this, I'm going to show you processes that work for any power, okay? And we need to notice the pattern. Pattern of i's to different powers. I to the first power is what? Yeah, okay. I squared is what? Negative 1, okay. I cubed. Well, I cubed is negative 1. It's I squared times I, right? Negative 1 times I, which would be what? I squared times I is, yeah, negative I. Alright, I to the fourth is negative I, or I cubed, right, is negative I times I. Maybe I'm confusing us here. Maybe let's think of it as I squared times I squared. Yeah, positive 1. Alright, what is I to the fifth? How did you get that? You just guess? The pattern? Alright, I to the fourth times I is I to the fifth, right? Correct? I to the fourth times I is I to the fifth? What's I to the fourth? 1. Okay, so 1 times I is I. Does that make sense? I to the sixth is what? Yeah, it's I to the fifth times I, which is I times I, negative 1. Alright, I to the seventh is negative 1 times I. I to the eighth is 1. Alright, so we have this repeating pattern that will go on forever, right? We start off with I. So raise the first power. Raise the second power, you get negative 1. Raise the third, negative I. Fourth, 1. Fifth I. Sixth power is negative 1. Seventh power is negative I. Eighth power is 1. So you see the repeating. How often does it repeat? Every 4. Alright, so what's I to the ninth power? I to the ninth power is I. Alright, let's try I to the 85th power. Well, that one's not very interesting.
Wouldn't you just divide that? Or just
Divide, okay. So the ones I'm concerned about really is, when is it 1? I to the fourth is 1. I to the eighth is 1. What's the next one that's 1? 12. Every 4, right? I to the 16th. So what is in common of all these exponents? They're divisible by 4, right? Okay, so what I want to do is say I to the 85th is 85 divisible by 4. No, it goes in it goes in 21 times. And we have a remainder of 1. Okay, so what I would say is I to the 84th power, and I have a remainder of 1i. 84, I to the 84th is 1, right? So my answer is I. Okay, let's try I to the negative 17th power. Well, how do you deal with negative exponents? Alright, write it as a fraction. 1 over I to the positive 17th power. Now we simplify I to the 17th power. How do we do that? Oh man, I'm getting sick of, these are all the same. I can't believe I picked all these. Yeah, it's I again. Let's practice I to the negative 18th power just to make it interesting. I to the negative 18th power. Oh, I'm sorry, 19th. 19th is more interesting. Okay. So it's 1 over I to the 19th. So what is I to the 19th power? Well, I to the 19th is not divisible by 4. What's the smallest number? The largest number below it? 16, right? So we can write as I to the 16th times I to the what? I to the third. What's I to the 16th? It's just 1. All right, so what's I to the third power? Negative I. It's not simplified because we have an I on its denominator. How do we get rid of that? Multiply by I over I. What does that give us? I over negative I squared. Okay, so we have a negative. I squared is negative 1. That makes positive 1, so the answer is I again. It'll all work, but yeah. I to the negative 19th power is I. All right, any questions? All right, last thing I want to say for this lecture is where these complex numbers fit into the real numbers system, or more so, where do the real numbers fit into the complex numbers? Okay, every real number is also a complex number. It's kind of confusing, but remember, complex numbers are A plus BI, right? So what's your favorite real number?
1.
All right, 1, 2, okay. Let's say 2 is my real part, and my imaginary part would be 0i. Does that make sense? So 2 is actually a complex number, where the imaginary part is 0. Does that make sense to you? So any real number you have, 3.753, is actually a complex number because you can put 0i on it. Is every complex number also a real number? No. 7 plus 2i is not a real number. It is only a complex number. So all real numbers are complex numbers, but not all complex numbers are real numbers. All males are humans, but not all humans are males, right? All right, any questions? All right, go ahead and take a 7-minute break.